When we think of a language like English or Spanish, we think of it as containing thousands and thousands of words. But not so with the C programming language. In fact, the C language contains very few words, called keywords. The C language itself is powerful, but there are many things programmers would be hard-pressed to do with just the vocabulary of C. To enhance the C language, programmers have created libraries of functions that allow us to make our programs more productive. Instead of having to write the functions ourselves, we can simply use what others have already programmed for us. In this video, we'll look at some of the functions inside the C math.h library. In case you haven't examined functions before, it's important to know these facts. First of all, a C function is like a small program inside a program. We're going to be using the ones written for us by other programmers. Pretty soon you'll be writing your own. Another thing, you can send pieces of information to a function. These pieces of information are called arguments, and we put them inside the parentheses after we put the function's name. But here's something really important. No matter how many arguments I send to a function, whether it's no arguments or 1 or 15, the function itself can only return one value. Now that value might be one character, one number, or some other type of data that we'll look at later on. The C math library has many functions, but we're just going to look at a few that are going to be useful for our class. Notice this table shows the name of the function, what data types we can send to the function as arguments, and what the function will send back to us. So let's set up a program and declare some variables. Notice that to use the functions discussed in this video, you must include the math.h library in your program. Since each of these functions returns a double, we'll make the answer variable a double too. Then we'll take a look at these functions one at a time. Using in1, an integer, as an argument, take the square root and print it. In other words, if we multiply the result, that 3.6055 something, times itself, we would get 13. Now use D2 as an argument. As expected, the result is pretty close to 2 since D2 is close to 4. Now use D4 as an argument. Because we're dealing with real numbers, trying to take the square root of a negative number yields something that is not a real number. As the output indicates, the result is saying not a number. That's what the NaN means. Finally, to show that these functions work with literal values as well as variables, let's use an argument of 64 for the square root function. As expected, the square root of 64 is 8. Okay, that's encouraging. Now let's go on to the absolute value function. One way to view absolute value is as the distance in units that some value is from 0 on a number line. So if I use a positive value as the argument, here D3, I get a positive answer because 17.005 is 17.005 units from 0 on the number line. On the other hand, if I use a negative value as the argument, like D4, I get a positive value because negative 2.6 is 2.6 units from 0. And if I send 0 to the function, I get back 0 because 0 is 0 units from 0. Well, that makes sense. Let's keep going to the next function. Think about the ceiling in your house. It's above you, right? Can you touch it? Well, you can if you're tall enough. But can you reach higher than the ceiling and still have it intact above you? Well, the answer is no. So your ceiling acts as an upper limit on how high your reachability can go. Same way with the ceiling function. It gives you the smallest whole number above the value you send it. Now think about that for just a second. It sends you the smallest whole number above the value you send it. Here's what happens when I send the ceiling function D1. It returns the value 2 because 2 is the smallest whole number above 1.35. What if I send it D3? Now it sends back 18, the smallest whole number above 17.005. But would it work with negatives? Let's try D4. Here we get a return value of -2. Why? That seems kind of weird. Well, it's because -2 is the smallest whole number above -2.6. If that's not clear, just draw a number line with -2.6 and then -2 and 0 on it, and you'll see why it works that way. Sending the ceiling function a whole number will return that whole number. It's like my analogy of the ceiling in your house. It's above you in general, but you can touch it. Here a whole number is touching its ceiling.